Up until now, we have been using the fundamental theorem of algebra, Descartes' rule of signs, finding the zeros of the functions, and our solutions have always been real numbers. Today we're going to do the same thing. We're going to figure out how many solutions, we're going to look at the sign changes, and we're going to find the solutions, but some of them might not be real numbers. So the fundamental theorem of algebra basically says that the number of solutions matches the highest power. Descartes' rule of signs talks about how many positive real roots we're going to have. The number of sign changes tells us the positive real roots, or less by 2, and then the negatives have to add up to the total, and then the steps for finding all of the zeros are written there. Let's go to the next page. We're actually going to scratch out example 2 and write a different problem in its place. So the one we're actually going to do is f of x equals x to the 4th plus 5x to the 3rd plus 10x squared plus 20x plus 24. Okay, previously, all of our problems were x to the 3rd, and now we're starting with an x to the 4th. So this is a bigger polynomial than the ones we've done before. First thing we still need to consider is how many solutions. And the number of solutions is tied to the largest exponent. So there are going to be 4 possible solutions. Then the type of solutions. And I like to just write a plus and a minus. That way I don't have to write out positive, negative. The positive solutions are determined by the sign changes. It seems to me that the sign changes is sometimes the most difficult part of this, just because it's not the way that you've ever thought about this kind of math before. This first term is positive. We're starting positive. We have 0 sign changes. We stay positive, stay positive, stay positive, stay positive. Are there any sign changes at all in this polynomial? So there are going to be 0 positive real solutions, which means how many negative solutions could there be? 4, or 2, or 0. Descartes' rule of signs says or less by 2. So 4 or 2 or 0. We're really hoping it's 4 or 2 and not 0. But we definitely do not want to test our positives. We want to test our negatives, because if there are any real solutions, they are going to be negative numbers. 24 is going to tell us what our possible solutions are. How can you multiply to get 24? 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And we're going to test the negatives, so the negative version of these numbers are the possible solutions. Okay, you ready to test them? We test using synthetic division. So if I test -1, we're going to have more terms inside the synthetic division because we have more terms in our original problem. So 1x to the 4th, 5x to the 3rd, 10x squared, 20x, 24. Do the synthetic division. -1. Did it work? No. So next, I'm going to test -2 and see if -2 works. Yay, it works. Okay, so this one works. That means that -2 is a solution. We could go all the way to the bottom of the page right now and write x equals -2. -2 is definitely one of our solutions. And this means that the factored form has an x plus 2 in it. So this -2 that we tested, that gives us the first part of our factored form. The second part of our factored form comes from the result of that synthetic division. Now, normally we've been writing x squared, but that's because we started with x to the third. This time, we started with x to the fourth, so our first term is going to be x to the third. Your first term after synthetic division always decreases the exponent from the original by 1. Whoa, sorry. So x to the third plus 3x squared plus 4x plus 12. Now we need to factor the blue part. How do we factor something that is 4 terms? We split it. So that yellow x plus 2, we're just going to be like, sit there and chill for a minute while we deal with this 4-termed polynomial. What do x to the third and 3x squared have in common? X squared, and that would leave us with x plus 3. What do 4x and 12 have in common? 4. So that part factors into x squared plus 4 times x plus 3. This is now fully factored, and we need to put it equal to 0 so that we can solve it. Okay, our solutions. X plus 2 is going to give us the solution x equals -2. And we knew that from the synthetic division. That synthetic division gave us -2 as a definite solution. X plus 3, that's going to give us a solution of x equals -3. And now we just have to figure out what this x squared plus 4 is going to be. Put x squared plus 4 equal to 0. How would you solve this equation? Subtract 4. So x squared equals -4. Square root. And when we put a square root in, we have to put a plus minus in front of it. What is the square root of -4? It involves I because there's a negative. The square root of the negative is going to be the I. What's the square root of +4? 2. So x is going to equal positive or negative 2i. Now remember at the very beginning we said there was the potential for 4 solutions. This looks like 3 solutions, but it's actually 4 solutions. We've got positive 2i, negative 2i, -2, and -3. That is all 4 of the solutions. Descartes' rule of signs told us how many possible positive or negative real solutions. There were only 2 real negative solutions. So Descartes' rule of signs said there would be 4 or 2 or 0. We had 2 negative solutions that are real numbers, and then the other 2 were imaginary solutions. On your online assignment today, there's only 2 problems on your online assignment. It'll have a whole bunch of possible solutions, and you'll have to select which ones are the solutions. You have to make sure that you show your work. I was going to do example 1 with you. Basically, if you start with x to the 5th, you do this top process where you get down to this part that's yellow and blue, and then the blue part requires you to do the whole process with testing with synthetic division again before you can factor the 4-termed polynomial. So it's just extra steps. But I'm not going to give you that in the assignments, so I don't want to bother you with it. The one thing I do want you to write down over here, what if we factored something and we ended up getting these 4. So 0 equals, why can't I move this? 0 equals x plus 1, x minus 2, x squared plus 9, x plus 1. X plus 1, what's the solution there? Negative 1. X minus 2, the solution is positive 2. X plus 1 at the end, the solution is negative 1. Do you see how 2 of these solutions are negative 1? And then there's a solution of 2. What about x squared plus 9? 3i. Because we would subtract 9 on both sides, and then square root, you'd end up having plus or minus the square root of negative 9. Anytime you end up with the square root as your answer, if there's a negative under it, that means there's an I. So this would be x equals positive or negative 3i. This one technically has 5 solutions, but 2 of the solutions happen to be the same solution, so there's really only 4 solutions. All right, your assignment is an online assignment. There are only 2 problems on the online assignment, and they are very, very similar to this example number 2 that we worked out together. So you are going to want to have a piece of paper in front of you, because if all you do on the online assignment is click answer choices and then say check answer, you have really not gotten any practice whatsoever, and you will have no idea how to do this on the test. So get out a piece of paper. Just plan on using one side for the first problem, the other side for the second problem. Do I need to require you to turn in the paper to make sure that you actually show your work? No, you're going to show your work. You're definitely going to show your work. You better show your work. I'll be walking around and checking.